So let's start. Okay, so numbers lecture 2. We learned in the theory class. Related to that, the questions we are discussing now. Prime number related questions we will first take. Prime number, how to identify them and what all are the properties of prime number we discussed in that class. So the first question is this: June 2019 net exam problem. This is how to identify the prime number. As you people already tried the question, I am not giving time for these questions because yesterday I already showed this question. So I will just start explaining this question. So this question, which one of the following numbers is a prime number is the question. So to identify prime number, the properties or the rule I have told or the shortcut method I told can be used here. But before that, first eliminate two options at least, because these two options can be clearly eliminated, because we know that this is going to be a multiple of 3, this is going to be a multiple of 11. Because when you see 183, the thought that should come into your mind is 180 is a multiple of 3. So 180 plus 3, 183 also should be a multiple of 3. At least one extra factor other than 1 and 183 means it is not a prime number, as we discussed in the theory class. So definitely 183 is not a prime number. 121 is clearly 11 into 11. 11 into 11. So 11 is an extra factor other than 1 and 121. So those two are not prime number at all. Without any doubt, you can say that. You don't have to check each and every numbers with the prime number method. That is going to be time consuming. That is why eliminating A and B is the first thing you have to do. C and D, if you are good enough with math or if you are good enough with speed math, you can eliminate option D. But I don't think all of you know it, that 102, 102, 101 is 101 square. 101 square means this is 101 into 101. But to identify that will take time. That is why instead of that, we can check whether the third option is prime number, because that is comparatively smaller value among the two remaining options. So 157 you take and try to check whether it is a prime number using the shortcut method I told you. Normally if 157 is prime or not, to check you have to check by all the small possible numbers 2, 3, 4, 5, 6, 7, 8, 9 up to 156. But that much time we don't have. That is why we just check square root of 157 approximately, that is 13. Because 169 square root is 13, so 144 square root is 12, 157 square root will be 13, approximately 13. The prime numbers below 13 only you have to check. The the divisibility test with respect to those numbers only are needed to check. Those numbers means 2, 3, 5, 7, 11. These are the 5 prime numbers below this 13. The approximate square root 13. So test the divisibility of 157 with respect to these 5 numbers. 2 not possible, 5 not possible, because for 2 and 5's multiplicity, last digit should be even number or last digit should be 0 or 5 ending. Both are not happening. That is why we can say 157, 2 is not a factor, 5 is not a factor. Now the remaining 3, 7, 11. 3, 7, 11, 3 you can clearly check by checking the sum of digits. 1 plus 5 plus 7, 6 plus 7, 13, not a multiple of 3. So 157 also not a multiple of 3. 7, how to check? The method I taught for test of divisibility of 7. 7 double 14, 14 subtracted from 15. Last digit double it. Subtract that double of the number from the remaining number 15. 15 minus 14 is 1. 1 is not a multiple of 7. That is why 157 is also not a multiple of 7. That is how you can eliminate 7. Now 157, how to check with 11? 1 and 7 addition is giving you 8. The remaining term is 5. So 8 minus 5 is 3. That subtraction is giving you a non-multiple of 11. That is why the number is also not a multiple of 11. Test of divisibility rules we learned in the theory class is enough to find that whether it is prime or not. So it is not divisible by any of those numbers below 13. That means 157 should be a prime number. We have proved it. That means option D you don't have to check, because only one option can be the answer, na? So option C is the answer. So option D will not be the answer. That is how we can say 157 is the answer. Now perfect square related question. Perfect square related theory we discussed in detail in the theory class. With the help of that, you can easily find perfect square or not the given terms. For example, this was a question which came in December 2014 NET exam. Which of the following numbers is a perfect square? I have already given time for trying this question, so I think I will start explanation in 10 to 20 seconds. Okay, so I will start explaining. Which of the following is a perfect square? I told you to identify perfect square. These are the facts I taught you. Last digit of a perfect square, a unit digit of the perfect square, can only be 0, 1, 4, 5 and 9. These are the possible last digits for a perfect square. That means the remaining numbers 2, 3, 7, 8 cannot be last digit of a perfect square. 2, 3, 7, 8 ending perfect squares does not exist. That means option B and D can be eliminated clearly due to the last digit itself. Now, if you think about the tens digit, that is second last digit, tens digit can be what, tens digit cannot be what, that also we discussed. That depends upon the unit digit. If unit digit is 0, tens digit compulsorily should be 0. Tens digit compulsorily should be 0. I will denote that here. Tens digit can only be 0. If last digit or unit digit is 5, tens digit can compulsorily be 25 or 2. Sorry, 2. Now, 1, 4, 9, these are the three possibilities. The remaining thing, 1, 4, sorry, I have missed the number 6 also. In the possible last digits, I forgot to write the number 6. So you can write 6 also here. 2, 3, 7, 8 is impossible. All others are possible. When it is 6, it should be an odd number only. It can only be an odd number in the tens place. In the tens digit, it can only be an odd number. But option C is violating that. Because 6 in the last digit, but tens digit, it is an even number 2. That cannot be a perfect square. 26 ending, 46 ending, 66 ending, 86 ending, 06 ending. All these possible, all these cannot be perfect square at all. So if it is 6 in the last digit, tens digit should be compulsorily odd number if it is a perfect square. And that is the reason we can eliminate 3 options. B, C, D options can be eliminated. So option A is the answer. Because practically taking the square root and checking whether square root is a natural number or not, that is very time consuming. That is how you have to observe this. Yeah, in the theory class I told you all other remaining possibilities, it should be only even number. 1, 4, 9, for all those 3, tens place can only be even. Whichever even number is possible, 0, 2, 4, 6, 8, any of them can be possible. So the next question, December 2019 question on the same type. Which of the following 7-digit numbers cannot be perfect square? In the previous question it was can be perfect square. Here it is cannot be perfect square. Here the numbers are given, but x, y, z can be anything. That is the meaning of x, y, z. It can be any of the digits. 0 to 9, any of the digits can be possible. But that doesn't matter, na? To find whether the number is perfect square or not, last 2 digits is what we want mainly. Last 2 digits. Look at the last 2 digits here. If you are thorough with the theory, by looking at the last 2 digits, directly we can say option D is the answer. Which of the following cannot be perfect squares? All the 3 cannot be perfect square at all. Why? C is not perfect square because 0 ending number, it should be 0, 0 ending. I told you if tens unit digit is last digit or unit digit is 0, tens digit can only be 0. Now option B is not possible because 5 ending unit digit 5 means tens digit can only be 2. 75 ending perfect squares does not exist. So B and C cannot be perfect square. Now 26, due to the same reason we discussed for the previous question, 26 ending perfect square does not exist because if unit digit is 6, tens digit can only be an odd number. Any of the odd number 1, 3, 5, 7, 9 is possible, but 2 is not possible because 2 is an even number. That is why option D is the answer. All 3 of them are not perfect squares at all. This was the December 2019 NET exam question. This was a theory I have taught in the previous classes. The squares, the properties. This table summarizes all the things needed for these 2 questions or perfect square identification related question, and the second table gives you the summary, the first 60 perfect squares to make you understand it with the practical examples itself. So if that is clear, let's go to the next question. Next question is regarding laws of exponents. Laws of exponents regarding theory we have discussed in detail. When base are same, how to multiply and divide? These two. When the power are same, how to multiply and divide? These two. When power of power comes, what to do? And what is negative power, what is fractional power, what is zeroth power, and what is mixed power? These things we have discussed in the theory class. So this is the question regarding laws of exponents, came in December 2015 question paper. I think this also you have tried, so without much delay I am starting the explanation for this question. How many digits are there in 3 raised to 16 when it is expressed in the decimal form? First of all, you have to understand decimal form means normal form. Normal form means decimal form means not decimal point. Decimal form means the form which is normal decimal in the numbers, in the decimal number system. That means 3 raised to 16 should be simplified to a normal number. That is what I am saying. That normal number will have how many digits? Or simply speaking, you are asked to find square 3 raised to 16 value and then count the number of digits. But exactly finding 3 raised to 16 is going to be very challenging, because 3 raised to 4, 3 raised to 5, that much is okay. After that the numbers are very big. So your understanding of laws of exponents is very needed for simplifying this fast. Laws of exponents, you can use the formulas I have taught you, but rather than that, if you can do it logically, that is much better. 3 raised to 16 means what? 3 into 3 into 3 into 3 into 3 into up to 16 times you are multiplying 3's. So to simplify it, we want to make the power small. To make the power small, you have to make the base larger. The base and power you have to manipulate. If you combine 3 and 3, you will get a 9. Na? Every 3 and 3 will give you a 9. 16 3's are written here. So how many 3 and 3's you can combine? Sorry, how many pairs you can make? 8 pairs you can make. That means you can make it 9 into 9 into 9 into 9 8 times. That means, simply speaking, 3 raised to 16 is 9 raised to 8. Same idea, 9 raised to 8, 9 and 9 combined, 9 and 9 combined. How many 9's and 9's can be combined? 8 9's paired means you will get 81 into 81 into 81 into 81. That is nothing but 81 raised to 4. Now it is easier to find the number of digits, because you are not supposed to find the exact value, because that is time consuming. As you know, in CSIR-NET exam, calculators are not allowed as of now. So 3 raised to 16 I am writing 9 raised to 8. 9 raised to 8 I am writing 81 raised to 4. You can do this mathematically also, because 3 raised to 16, mathematically how you can make it 9 raised to 8? 3 raised to 16 is nothing but 9 raised to half, square root of 9 raised to 16. Now this is a raised to m the whole raised to n formula we learned earlier. That is 9 raised to half into 16, that is 9 raised to 8. That way also you can say it is 9 raised to 8. It is up to you which way, but I will suggest try to do logically rather than mathematical. This is mathematical. Imagining like 3 3 3 3 written 16 times and thinking in the head and pairing up, that is much better than mathematically writing the step. Anyway, 81 raised to 4 you got. 81 raised to 4 I want to estimate it. 81 raised to 4 is little more than 80 raised to 4. 80 raised to 4 is what? 8 raised to 4 into 10 raised to 4. Because 80, 80, 80, 80 multiplied. That is 8 into 10, 8 into 10, 8 into 10, 8 into 10. 10's if you combine you will get 10 raised to 4. 8's if you combine you will get 8 raised to 4. Approximately 81 raised to 4 will be little more. But we want only the number of digits. Now. So the number of digits from 80 raised to 4 going to 81 raised to 4, that chances of becoming to the next level is very less. Yeah, that we will check towards the end. 8 raised to 4 into 10 raised to 4 you can estimate. Now what is 8 raised to 4? 8 raised to 4 means 8 into 8 into 8 into 8. 8 into 8 is 64. Another 8 into 8 is 64. So it is 64 square into 10 raised to 4. 64 square into 10 raised to 4. 64 square you can easily say how many digits they have. How you can say? You have to estimate it. Look at this estimation. You can easily estimate it. 60 raised to 4 is what? 3600, because 60 square. 60 square is 3600 now, because 6 square 36, 60 square 3600. 70 square is 4900, because 7 square is 49, 70 square 4900. 64 square is anyway in between these two, na? That is enough to say that 64 square is going to have 4 digits. We don't know exactly which are the digits, but we are 100% sure that this will have 4 digits only. 4 digit number into 10 raised to 4 means what? We don't know which are the 4 digits, so I will just call XYZP. Into 10 raised to 4 means put 4 zeros in the end. That means total 8 digits will be there. That means option D is the answer. Is it clear to all of you? Option D, 8, how it is the answer? Because we can say 80 raised to 4 is approximately 64 square into 10 raised to 4. 64 square will be a 4 digit number because 60 square also is 4 digit. 70 square also is 4 digit, means 64 square, which is in between them, definitely can only be 4 digit number. Because in between a 4 digit and 4 digit number, how can there be a 5 digit or 3 digit number? Impossible, na? We have covered whatever we have yesterday. We were not able to finish that much. We covered now. Now we are going to go to the next question. In case there is any issue, you can report in the WhatsApp group or you can just message in the chat. Okay, so this question, 8 digit number will be the answer, option D. Next question from the same laws of exponents itself. All of you try. This is 1 by 1 2 3 4 and minus 1 by 1 2 3 4. Yes, okay. So all of you are able to continue. Try the question, I guess. If so, I will start explanation. Okay, so I'm starting the explanation. Here the question is asking, let R be a positive number satisfying R raised to 1 by 1 2 3 4 plus R raised to minus 1 by 1 2 3 4 equal to 2. Then R raised to 4 3 2 1 plus R raised to minus 4 3 2 1 is what? So here solving mathematically is not the idea. Logically think about it. Taking example method is the best method. In the shortcut methods class I told you, you can take examples for some question which will solve the question much easier. Examples means just think which R will satisfy this condition easily. Not mathematically think, just primary understanding about powers is enough. R raised to something plus R raised to something is equal to 2. That means something, one number's power plus R raised to 1 by 1 2 3 4 plus R raised to minus 1 by 1 2 3 4 means 1 by R raised to 1 by 1 2 3 4. This sum should be 2. That means a number plus a number should be 2. Or in other words, we can say a number plus its reciprocal should be 2. A number plus its reciprocal 2, the best example you can take is 1 plus 1 by 1 is 2. That means when R raised to 1 by 1 2 3 4 is 1, that is the simplest example you can take. So R raised to 1 by 1 2 3 4 is 1 means what should be R? R should be 1 itself, because only for R equal to 1, R raised to 1 by 1 2 3 4 is going to be 1. So we can say R, this value is 1, this value is 1, that means R is 1 itself. You got the value of R means you don't have to mathematically solve it to find the value of R, na? Now just substitute that 1. 1 raised to something plus 1 raised to minus that same something. 1 raised to anything is going to be 1 itself. So 1 plus 1 again 2 itself. So option A is the clear answer. Very simple if you are logically thinking the basic math you know. So option A is the answer. Let's go to the next question from laws of exponents itself. This was a question which came in December 2019 NET exam. All of you make an attempt. In 3 different NET exams they have asked to compare values which is larger. This is one of them. 2 more questions like this was asked in previous NET exams. So first try this question, after that I will show you a similar question. Okay, I think all of you tried. Here the concept of factorial should be clear. I am sure that you all know factorial. In case you have forgotten, 2 factorial is 2 into 1. 3 factorial means what? 3 into 2 into 1. 3 into 2 into 1 is 6. 6 raised to 1 by 3 means 4 third root of 6. Third root of 6. This is 2 into 1 the whole raised to 1 by 2, which is nothing but square root of 2. This is 3 into 2 into 1, which is 3 factorial. Raised to 1 by 3 means 6 is the base. 6 raised to 1 by 3 means cube root of 6. And what is this? 4 into 3 into 2 into 1 raised to 1 by 4. 4 into 3 into 2 into 1 is 24. 24 fourth root. And finally 3 factorial is 3 into 2 into 1 divided by 2. That is nothing but 3 itself. These 4 values you are asked to find which is the largest among them. Which is the largest among them. Here the best thing to do is pair by pair eliminate it. Because making all the finding all the values and comparing will be time consuming. Logically, if you eliminate them, that is better. First of all, option A can be eliminated because you already know a better or larger value than that. Which is that value? Option A is root 2. This is 3, na? Root 3 itself is greater than root 2. So definitely 3 will be greater than root 2 for sure. So the largest cannot be option A because we already know a larger number than root 2. Now option B and option D we will try. D is the only value we clearly know, 3. So we are comparing every other values with 3. Cube root of 6. Think about cube root. We know that cube root means if cube root is confusing you, think about cubes. 1 cube is 1. 2 cube is 8. 2 cube is 8 means cube root of 8. Cube root of 8 will be 2, na? Cube root of 8 is 2 means cube root of 6 is going to be less than 2. So option B is going to be less than 2. Option D is 3. That is why we can say option B is not going to be the answer because we already know a value more than option B, which is option D. Now only 2 options are remaining, option C and option D. Option C is what? 4th root of 24. Whether 4th root of 24 is greater than 3 or less than 3, that is the confusion we have. How to clarify that confusion? Think about 4th powers. 1 raised to 4 is 1. 2 raised to 4 is 2 into 2 into 2 into 2, 16. 3 raised to 4 is 3 into 3 into 3 into 3, 81. Look at this. 3 raised to 4 is 81 means 4th root of 81 will be 3. 4th root of 81 is 3. So 4th root of 24 will be less than 3. That is enough to say that option C also cannot be the answer because option C is less than option D. So option D only can be the largest among these 4 options. If that is clear, another way they have asked laws of exponents is this. Whether your tower rule idea is clear. I have taught you tower rule in detail in the theory class. Please apply that and find the answer as soon as possible. It hardly takes 10 seconds if you know the theory well. Okay, so I will start explaining. 2 raised to 2 raised to 2 raised to 2 is what we have to find. 2 raised to 2 raised to 2 raised to 2, there is no brackets means I told you tower rule you have to apply. The topmost step have the preference. The priority should be given to topmost step. That is why we are putting a bracket to denote that that is the first step. So 2 raised to 2 should be done first on the top 2 raised to 2. That is 2 raised to 2 is 4. That means the top part 4 you are replacing here. Now how to decide the order? Again top to bottom order. Now 2 raised to 4 you do. 2 raised to 4 is what? 2 raised to 16. And answer options is giving you a value 2 raised to 16. So you don't have to simplify it more. You only have to reach 2 raised to 16 and say that is the answer. So option C is the answer. Again repeating, if anyone have doubt, 2 raised to 2 raised to 2 raised to 2. First you are finding that 2 raised to 2 4. Now you have to decide the order. 2 raised to 4 you do first. 2 raised to 4 is 16. That is why 2 raised to 16 is the answer. Another question from laws of exponent which came in June 2019 NET exam, which was asking again which is the largest among the 4 expressions. I will first show you the mathematical solution. Here the problem is the base are different, power are different. If base is same or power is same, you could have easily compared it. So either make the base same or the power same. That is what we are trying. Making the power same is easy because powers have a common multiple of 10. First I am telling mathematically, then I will tell you the shortcut. So 2 raised to 50, that common 10 you are trying to take out. How you can take out? 50 you can write 5 into 10. 5 into 10 is what? You can write it as 2 raised to 5 the whole raised to 10, because you know a raised to m into n is a raised to m the whole raised to n. You are writing RHS equal to LHS in the property we learned. A raised to m the whole raised to n is a raised to m into n. Same property you can apply for 3 raised to 40 also. 3 raised to 4 into 10, which is 3 raised to 4 the whole raised to 10. Now you can find the bracket means that bracket can be done first. I told you the other method is just a shortcut for doing so. 2 raised to 5 the whole raised to 10 means what? 2 raised to 5 which is 32, 32 raised to 10. Same way 3 raised to 4 is 81, 81 raised to 10. Then option C is giving 4 raised to 30. That can be similarly written as 4 raised to 3 the whole raised to 10 which is 64 raised to 10. And option D is 5 raised to 20 which is 5 raised to 2 the whole raised to 10 which is 25 raised to 10. Now everything is in the terms of power of 10. If everything is in terms of power of 10 means you can compare the bases. Whichever base is larger will be the answer. Which base is the largest one? 81 raised to 10 have the largest base. So option B is the answer. 3 raised to 40 will be the answer. But once you understood the idea that you are taking out the 10, take out the 10 without actually thinking anything, because you know what is happening. This 10 as it is common, that does not matter. So delete that, and the remaining 2 raised to 5 find is 32, 3 raised to 4 it is 81, 4 raised to 3 64, 5 raised to 2 25. Here 81 is larger, so option B is the answer. For the exam sake, this much is enough. And I will show you the same question asked in a previous NET exam with a slight change in the values. June 2017 NET exam this was asked. So here you don't have to go for the mathematical idea we discussed. Here just cancelling common powers are enough. 500 is 5 into 100, 400 is 4 into 100, 300 is 3 into 100, 200 is 2 into 100. That 100 is going to be taken out common, so that 100 we are deleting. Now remaining thing you find, 2 raised to 5 is 2 into 2 into 2 into 2 into 2 32, 3 raised to 4 is 81, 4 raised to 3 is 64, 5 raised to 2 is 25. The largest among them is 81, so option B is the answer. Literally this is the same question as previous question, just the 50, 40, 30, 20 they are replaced by 500, 400, 300, 200 respectively. Otherwise mathematically this is what is happening. That much step you don't have to write at the time of exam. Anyway, same option B itself is the answer. Instead of multiples of 100 or 10, they can give multiples of 5 or multiples of 3. Then also you have to take the same. For example, if it is 2 raised to 15, 3 raised to 20, 4 raised to 30, 5 raised to 4 raised to 9, 5 raised to 10. That way also question can come. Yeah, there it will be difficult to find the common factor. You can think about 2 raised to 15. If the question was asking 2 raised to 15, 3 raised to 12, 4 raised to 9, 5 raised to 6. There the common factor is 3. As much big common factor you can take, that much easier will be the simplification. So you can write it as 2 raised to 5 the whole raised to 3. This is 3 raised to 4 the whole raised to 3. This is 4 raised to 3 the whole raised to 3. And 5 raised to 2 the whole raised to 3. Then find what is there in the bracket. There common factor is 3. So accordingly the question will change, that's all. So anyway, one more question from laws of exponents, which was checking whether you are able to find, whether you are able to simplify this powers conveniently. Okay, so I'll explain I guess. Which of the following numbers is the largest? Here also 6 numbers are given. We want to find the largest among them. Even if 6 numbers are given, in the answer options 4 possibilities only are there. Na? So don't waste your time on the remaining options. Remaining values that are not there in the answer options. Just consider the 4 answer options. Among the 4 options, how to simplify it, that is what we are thinking about. 2 raised to 3 raised to 4 is, I told you when there is no bracket, you have to start from the top. So this topmost step you can do, tower rule. 3 raised to 4 is 81, 4 square is 16, 3 square is 9, and 2 cube is 8. Among these 4 values, which is the largest is the question. Just like we did in previous question, previous question means that factorial related problem. Here also we can do the same. Pair by pair we can compare. Option D cannot be the answer because 4 raised to 9 is even bigger than that. So option D is eliminated. Now 3 options are there. All those 3 options, the power is same. Power is not same. Base is not same. So you have to make it same somehow or compare it somehow. So here 2 raised to 81 you can write it in terms of 4 raised to something. then you can compare those two easily. So 2 raised to 81, how you can write it in terms of 4 raised to something? Again, you can visualize it. 2 into 2 into 2 into 2, 81 times. That's the meaning of 2 raised to 81. Now, pair it up. 2 into 2, another 2 into 2, another 2 into 2. How many 2 into 2 is possible? Try to pair it up. But finally, 1 2 will be there who didn't get a partner because 81 is an odd number. So, how many 2's you can pair up? 80 2's you can pair up to make it 4 into 4 into 4 into 4, 40 times. 40 times, but a 2 remaining. That means we can say it is 4 raised to 40 into 2. Yeah, that is what you are mathematically doing as 2 raised to 81 written as 2 raised to 80 into 2. Then 2 raised to 80 written as 4 raised to half the whole raised to 80. Then writing 4 raised to half the whole raised to 80 as 4 raised to 40. But that requires you to write steps. But the imagination, you don't have to write it. So anyway, option D is eliminated. This is 2 raised to 81. We wrote it as 2 times 4 raised to 40. 2 because that didn't get a partner. That is why we are not including it in the 40s. Now this is 3 raised to 16 and this is 4 raised to 9. Now look at A and C option. 4 raised to 40 itself is bigger than 4 raised to 9. So 2 times 4 raised to 40 will compulsorily be bigger than option C, 4 raised to 9. Huh? So option C cannot be the answer. Now A and B you compare. A and B you compare. A and B, 2 raised to 2 into 4 raised to 40, 3 raised to 16. Base are not same, power are not same, but 4 is greater than 3. Base is greater. And 40 is greater than 16. Power is also greater. If base and power both are greater means definitely 4 raised to 40 will be greater than 3 raised to 16. Huh? For example, 10 raised to 10 raised to 7 and 9 raised to 6. 10 is greater than 9. 7 is greater than 6. So definitely 10 raised to 7 will be greater than 9 raised to 6. Same idea here. 4 raised to 40 will be greater than 3 raised to 16. So 2 times 4 raised to 40 also will be greater than 3 raised to 16. We want to find the largest. We already eliminated option C and D. A and B is the only confusion we have. A option you wrote it as 2 times 4 raised to 40. And B option we wrote it as 3 raised to 16. As A option is greater than B option can be eliminated. So the largest can only be option A, 2 raised to 3 raised to 4. That is how we found option A as the answer. More explanations are given here. Mathematically speaking, this is how to convert it. But logically, you don't have to write that step. You can just think in the head. 2, 2, 2, 2, combining 44s will be obtained. Now some of you may be thinking that why didn't I convert 4 raised to 9 to 2 raised to something? That is easier, na? 4 raised to 9 written as 2 raised to 18 is much easier. But then you have to again convert this for comparing these two. That is why I didn't do so. For comparing last one with this one, I totally agree that 2 raised to 18 would have been easier. 2 raised to 18 is less than 2 raised to 81. But to compare with option B, that is 3 raised to 16, you have to convert 2 raised to 81 into 4 raised to something. Otherwise, you will not be able to do. So, to avoid 2 times manipulating 2 values, I just did 2 raised to 80 in comparison to 4 raised to something. So that you can compare it with this also at the same time. That is how you can save time. So, if so, let's go to the next question. Another loss of exponents problem, which came in December 2014 at exam. I think all of you tried. So here the question is asking to find the sum of digits of this expression. This is just an expression now. You have to convert it into a number. That is what they are saying, decimal number. Just like in one of the previous questions, the word decimal is not denoting anything regarding decimal point or anything. It is denoting the decimal number system number. That means a normal number. That means the first requirement is 2 raised to 7 into 3 raised to 5 into 5 raised to 6 should be simplified to form a number. And in the number, how many digits are there? That is the meaning of f of n. Sum of, not digits, how many digits? Question is asking what is the sum of those digits? All the digits added. They have given an example. If it is f of 137, you have to do 1 plus 3 plus 7. Similarly, this number you are finding n, find f of that number n. That should be the answer. So the challenging thing in this question, first of all you have to understand the meaning of the question. That is the first challenging thing. And I think you have understood now the meaning of the question. You have to find this number value and then find sum of digits of that value. So finding the number value, we will try 2 raised to 7 into 3 raised to 5 into 5 raised to 6. Here also you can mathematically do it and logically do it. Mathematically you can use the formulas and do it, but I will prefer logically doing it because that is how you can skip writing steps and save more time. First of all, to simplify this, finding 2 raised to 7, 3 raised to 5 and 5 raised to 6 is not a good idea because that much big multiplication without calculator, it is time consuming, very time consuming. You have to simplify it using 2's and 5's combined. 2's and 5's if you combine, you will get 10's. And 10's will make the expression simpler. As many 10's as possible you have to take out by combining 2's and 5's. What is the meaning of combining 2's and 5's? 2 raised to 7 means what? 2 into 2 into 2 into 2 into 7 times you are multiplying 2's. That is the meaning of 2 raised to 7. 5 raised to 6 means what? 5, 5, 5, 6 times 5's are there. Now if you multiply, multiplication is commutative and associative. Na? Anyway you have to multiply this and this. So whichever order it multiplies does not matter. 2 into 5 is a 10. Another 10. Another 10. How many 10's you can form like that? 6 10's you can form like that. After forming 6 10's, there is a 2 that cannot be combined because there is no more 5. There is only 7, 5, 6 5's, but 7 2's are there. That is why you can combine only up to getting 10 raised to 6. After 10 raised to 6, what is remaining? 2 into 3 raised to 5 is remaining. Because this 3 raised to 5 we didn't do anything. And the extra 2 also we could not combine. 3 raised to 5 is what? That you can calculate. 3 into 3 into 3 into 3 into 3. 3 into 3, 9. 9 into 3, 27. 27 into 3, 81. 81 into 3, 243. So 2 into 243 into 10 raised to 6. That is 486 into 10 raised to 6. 486 into 10 raised to 6 means what? 486 0 0 0 0 0 0. So we got the number. Now you just have to find the sum of digits of the number. Sum of digits of this number 486 0 0 0 0 0 0. That will be 4 plus 8 plus 6 plus 0. That is 18. This is a logical way of doing it. Once you practice it, you don't have to write any steps. You can do everything in the head. But in case you want to learn the mathematical method also, this is a mathematical method like we did in school days. Making powers same and then multiplying. This is exactly same as a logical method. But for mathematical method, you have to write each and every steps. That is why it is not advisable. But I am giving you both the options, mathematical direct method and logical direct method both. So let's go to the next question, which is very similar to the previous question. June 2014 NET exam problem this is. Okay, so I think I will start explanation. Here it is more simple because the question is not asking sum of digits. Question is asking number of digits. How many number of digits are there? So you just have to find the number and count the number. Count the number of digits. That is even easier, na? Here the powers are bigger, so the logical ideas will be more helpful. 2 raised to 17, you can think 2, 2, 2, 2, 2, 2. How many 2's? 17 2's. 5 raised to 14 means what? 5 into 5 into 5? 14 times. That means after that there will be 3 2's which will not get a pair. Because 2's are 17 in number but 5's are only 14 in number. So 2 and 5, 2 and 5, 2 and 5 will be combined 14 times. So you can say 2 raised to 17 into 5 raised to 14. You can write it as 10 raised to 14 into what is remaining now? 2 into 2 into 2, 8 is remaining. 3 square is there. 3 square is 9. And 7 is there. This 7. That means instead of multiplying very big number, the only 3 numbers you have to multiply is 8 into 9 into 7. 8 into 9 into 7. 8 into 9, 72. 72 into 7. Again you can estimate it like a previous question we did. 8 into 9, 72, 72 into 7. 70 into 7 is 490. Na? So 72 into 7 is going to be little more than 490 or it is going to be a 3-digit number only. Sorry, it is going to be a 3-digit number only. Yeah, that is what we want to know. 3-digit number into 10 raised to 14. 3-digit number into 10 raised to 14 means x, y, z, then 14 zeros. That's the meaning. Whatever is the x, y, z, that doesn't matter to us because we want to find the number of digits only. If the sum of digits was needed, I understand, I agree that you have to find exactly how many, what all are the digits. But here that is not necessary at all. So how many zeros? 3, 6, 9, 12, 14 zeros and 3 digits. So total 17 digits. Again, if you are not that okay with that simplification step I told or the 8 into 9 into 7 estimation step I told, then do with your normal idea 8 into 9 into 7. 8 into 9 into 7 into 10 raised to 14. 8 into 9 into 7 if you did, you will get 504. 504 into 10 raised to 14 means what? Not 4, 14. 504 followed by 14 zeros. So how many digits are there? Now it is more clear. 17 digits will be there. So that is the idea of this question, option D. Here sum of digits, if it was asked, 9 would have been the answer. Again, mathematical method also I am showing in case you want to learn it. How to make powers same and multiply it using the laws of exponents we learned. That is also practical if you want to do, but that may take more time because steps are needed for that. Okay, these two questions had a similar logic, but the previous question, I just forgot to mention, there is one more extra technique you can use here for this question. Without actually finding the number, we can find the value using the answer options, because answer options are that simple. But not using laws of exponents, but using test of divisibility. Listen very carefully, I am telling a second method for this question. We want to find sum of digits. Only because of that we can do this. 2 raised to 7 into 3 raised to 5 into 5 raised to 6. We want to find the value and then find the sum of digits. But without finding the value itself, we can say that 3 of the options cannot be possible. Which 3 of the options? Option A, option C, option D can be never possible in this scenario. Why? Because 3 raised to 5 is there means this is going to be a multiple of 3. Some 3k kind of number. 3k kind of number means multiple of 3 type of number. Multiple of 3. That means this given expression 2 raised to 7 into 3 raised to 5 into 5 raised to 6. When you are going to expand it and finally get the number, that number will be a multiple of 3. And you have to find sum of digits of a multiple of 3. Sum of digits of a number which is a multiple of 3. If the sum of digits is multiple of 3, the number also should be multiple of 3. So, the number is multiple of 3, we are 100% sure about, because there is at least one 3 in it. So definitely, its sum of digits also should be multiple of 3. That means answer is asking you sum of digits. That should be a multiple of 3. 10 is not a multiple of 3. Multiple of 3 means 3 into a natural number or 3 into an integer you should get 10. No. 3, 6, 9, 12, 15 etc. are the multiples of 3. So option A is gone. 28 also not a multiple of 3. 11 also not a multiple of 3. So the only option which is a multiple of 3 is 18. That is why that finishes the question. And this will save more time than even the logical method we discussed. Elimination using answer option here, just because answer option have a special property. If there are multiples of 3 in the answer option, you cannot do this method for sure. That's why I told it as a secondary method, but this will save more time. And this is the logical improvisations you can make in these kinds of questions. Normally, test of divisibility directly applied to a laws of exponents question comes very less. But here, you can use test of divisibility to solve a laws of exponents question. So try the next question now. This question is just checking whether you know zeroth power, fractional power, etc. Okay, so I'll start explaining. Here, these values you have to find and add it up. And the options are, most of the options are in mixed fraction form. So you may have to convert the final expression to a mixed fraction. So I will show you. 4 raised to 0, 4 raised to 4 square, 1 by 4 square, 4 raised to half, 1 by 4 raised to half. These are the values given in the expression. So find it. 4 raised to 0. Anything raised to 0 is 1 we discussed. 4 square is 16. 1 by 4 square means 1 by 16. 4 raised to half means raised to a raised to 1 by m is mth root of a. So 4 raised to 1 by 2 means square root of 4. Square root of 4 is 2. 1 by 4 raised to half means 1 by square root of 4. 1 by square root of 4 means 1 by 2. This you just have to simplify. Now, when simplifying, as I told, as there are mixed fraction answers, try to combine the natural numbers together and fractions separately. That is easier to do, because otherwise you have to make it in a improper fraction first and then simplify. That will be time consuming. So keep fractions as such. 1 by 16 plus 1 by 2. Now you can combine them using LCM only on the fraction part. The natural number part, let it be like that itself. 1 by 2 you can write 8 by 16 to make the LCM 16. 1 by 16 plus 9 by 16 is 1 by 16 plus 8 by 16 is 9 by 16. So 19 plus 9 by 16 will be the final value you are getting. 19 plus 9 by 16 are not there in the answer option, but 19 and 9 by 16 are there. Yeah, that they both are the same. 19 plus 9 by 16 is same as 19 and 9 by 16. Those people who are confused why they are same, that is a school day math. For example, if you get 1 mark and half mark for the second question, what you will say? You got 1.5 marks. 3 by 2 marks or 1.5 marks. So a plus b by c is nothing but a and b by c. That is just a notation of mixed fraction. So 19 and 9 by 16, which is given in answer option C, is the answer. If that option was giving 19 plus 9 by 16, that is also okay. Anyway, that was about laws of exponents. Laws of exponents related questions also we discussed. In the next class, we will discuss this thing, last digit of a power related questions.